So, hello everyone. Welcome to this very exciting session and very interesting session where we have a very special guest with us, Dr. Sudheer Kumar. Hello everyone. Welcome to this very exciting session and very interesting session where we have. Okay, so we are live now. Yeah, we are live now. All right, so welcome, Dr. Mila Mitra. Welcome, Dr. Sudhir sir. And we are very excited today for in learning all about the future of space exploration from you all. So, without wasting any time, so over to you, ma'am.
So, good evening, everyone. Uh, it is a great privilege today to introduce our distinguished guest today, Dr. Sudhir Kumar N. With a strong foundation in mechanical and industrial engineering, he began his journey at Tata Steel. In the year 2000, he brought that expertise to ISRO. He has held key roles establishing the solid rocket propellant plant at SDSC Shar, the Mission Control Center, assembly and integration facilities for the GSLV Mark III, and the second vehicle assembly building, which stands today as ISRO's largest rocket integration facility. Later, as the director of the Capacity Building Program Office, he shifted his focus to the future of the Indian space ecosystem. He has championed startup incubation, technology transfer, and most importantly for us here today, he has expanded ISRO's engagement with students and academic institutions across the country. Today, Dr. Sudhir Kumar N will be sharing insights about the future of space exploration in India and space careers. Please join me in welcoming Dr. Sudhir Kumar N. And over to you, sir. We look forward to hearing from you.
Thank you. Thank you. Probably, I think we have some students between the age group of 10 to 15, if I'm correct. Okay, good.
That's correct. Yeah.
Thing is, if I talk too much on the technical aspects, probably they may get bored. Okay, whenever a chance comes, let me just run through some of the clippings which it talks, which for kids, what is space, they'll get an idea. And for those who are enthusiastically looking for careers and let's say what they can do academically or research front, probably I think we will listen to them more in interaction. Let me just run through a couple of slides which I've just picked up for the kids. Hope the thing is visible.
Yes, it's visible.
See, just to give you a brief, the students nowadays, this generation students should understand how actually what is the importance of this space, how you are, let us say, connected with the space, why space is required. Everybody talks about space, space, space. And many people, they will be under the impression that space means rocket and satellite. What for this stuff? Amusement is fine. Looking at a rocket, a giant object roaring into the skies in a very majestic way and creating terrible sounds, acoustics, is fascinating to see. But what it does, what is the effort that was involved behind making such kind of gigantic articles which are flying through, and what are the technologies that are involved, how these technologies were mastered by Indian scientists, how they are going to grow, what it creates, impact to the society. These are all the subjects, one the students have to understand to create some kind of culture towards, I should say, creating the temperament and pursuing the careers and getting to know what is around them. Let us say I'll switch over to some other topic, probably, I think, mm, yeah, this one, yeah. If you see the topics around us, some kind of, if you go to Delhi kind of areas, huge emissions are there, which elderly people even they can't go out to take a fresh breath. India's industrial waste are being dumped. Global warming. Yesterday, last year, the temperatures were at the order of 42 degrees. This year, it may go up to 44. If the same trend continues, after 20 to 25 years, when you kids becoming old, maybe at the age of 60, 70, probably I think it will become another, what you call, Dubai or desert things. Fuel, it's getting, fossil fuel is getting consumed and the reserves are getting depleted. What do you do with that? Pollution, depletion of water, urbanization, mining exploitation, forest fires. See, all these things are disturbing our lives. You should understand why a space technology is required. A satellite sitting in the sky, looking at the Earth and observing 24 by 7, it gives you a good amount of information about whatever things are happening on the Earth. So the solutions, especially geo, we are depending on the Mother Earth. When we are depending on the Mother Earth, forget about the communication, the other let me say, sophistications. First is we have to live peacefully. We have to eat to the extent possible in a very healthy manner. We have to navigate ourselves to the office or to the schools or to the hospitals proper way. All these things are they possible using the space technology? The answer is yes. Let us say if you go to agriculture, in the using the space, you can identify which are all the fields that are green, where the water is available, where the agriculture 3 times in a year or 2 times in a year is possible, what is the yield, how much we are getting, how much is the surplus, how to do business out of that, how much we can export, how come we can consume, how to balance. Let us say if paddy is becoming too much, it is again becomes, if you don't have vegetables, if you don't have flowers, if you don't have horticulture, that is not the balance. How to balance your day-to-day requirements, yes, is a subject of the concern. Then it comes to the smart city. Then it comes to the smart cities. When you are living in the cities are becoming a traveling in a city is a nightmare, especially cities like, let us say, Bangalore or Hyderabad to some areas, Mumbai to some areas. If you go around, it's very difficult to come out. How actually you navigate yourself? How actually you live without proper pollution or proper, let's say, with proper ventilation, with proper connectivity? These are all the some of the problems, the solutions the satellites throw. If you say by and large, the satellite, what for it is, we can use the entire Earth resource management using the satellites. We can predict cyclones. We can identify the minerals and geology to explore the wealth. If water resources and fisheries below the ground and above the ground, and the rains prediction, everything we can predict well in advance and plan our resources so that we can be comfortably living our life. Agriculture is a major resource, rather area domain where satellite applications are used to the extent possible. So these are all called, we called as remote sensing or earth observation. How we should live our comfortable life. The satellite is like a catalyst or is like a helping tool for us to have a better life. Then coming to the communication. Today, without mobile, you just can't survive. How these mobiles are, earlier these mobiles were not there. And nowadays, mobile, if you have a mobile, you can operate your banking account, you can book your air tickets, railway tickets, you can get your pension for old people. Okay, you can pass time, you can watch cinema, you can do everything. If your brothers and sisters are there abroad, you can talk to them, video call you can make. This all sophistication has come out of communication technology. Today we have small satellites we have which will cover the low Earth orbits, so that our bandwidth has increased like anything. Not like earlier. Earlier these satellites will be in geo orbits, which are 36 kilometers away from the surface of the Earth. The fidelity is not that much comfortable. The low bandwidth rates are there. The response rate is very low. But nowadays, when you have a small constellation, you are seeing Starlinks, you are seeing OneWeb. So these new programs, new innovations are happening. When the satellites are coming into the low Earth orbits, you have comfortable what you call life using these gadgets. Navigation is another important area. When you just wanted to get into Uber car or Ola, without knowing anything, nobody can bluff you. You just put a map, whether this guy is going in the right direction or not in an optimum way, you can find out. If you order for a Zomato, when the Zomato is coming to your door, you can find out. The timing, the navigation, these are all some of the technologies which otherwise were difficult. They have reached the common man, and they made our lives very happy, because these are all because of the satellite and space technology. I've just depicted some of the examples which will show the agriculture. See, you can monitor the crops, you can monitor forecasting. Let's say 3 months before, what kind of crop is going to come. If you can estimate, you can just eradicate the entire, let us say, the food requirements of the country. That's what is happening. Once upon a time, you are falling short of your paddy, your rice, you are falling short of your horticulture. But today, we have surplus, and our godowns are filled with surplus grains, and we are exporting to multiple countries, even countries like USA. We are exporting. Did you imagine some time back? I'm not telling that this is all because of satellite, but with the satellite, you can optimize. This we call it as smart agriculture. You just put your mobile and connect your drone, standing at one place. You can just make a snapshot of the entire fields. You can throw fertilizers, you can throw pesticides, you can throw some kind of samples, you can collect everything, you can map it using your mobile. So this is the sophistication the satellites are giving you for optimizing the resources. Incidentally, there is a soil. Using the satellite, you can identify the soil moisture, and you can operate the sluice gates of all your water resources, so that water will never be wasted. So such kind of sophistication it is going on. And the same case with the forest. What the forest is doing is all ecological balance. If you want to have proper rain and proper temperatures, you have to balance the biomass, the carbon balancing you have to do. Without forests, your life is going to be horrible. So, how many forest fires are happening? And let us say unauthorized deforestation. If any cyclone or any reason the trees are falling, you have to reforest. For all these things, satellites are helping us. As I was telling, urban planning. So these are all the areas where satellite is helping us. Now, the question is what to do next? What have been doing? Is it the technology, or is it the exclusive resource only available with ISRO? See, today, maybe some time back, ISRO was only the agency managing the entire technology. ISRO only has to do the science missions. ISRO only has to support the agriculture, such kind of observations. Now private got opened up. In the 2021 reforms, government has announced the private sector to enter into the space domain. So with this one, what is happening? Exploration, exploitation of the space has come to a common man, or in education is even he comes out of the college, immediately he can jump into the entrepreneurship and he start pursuing the space technologies. Just to cover these, the technologies are because they require very deep technologies. Deep technologies are what are those technologies? See, when we have done this Mangalyaan mission, maybe 20 years back, if I'm correct, at that time, whatever the technology that we have acquired, reaching a satellite maybe 60 crore kilometers away in the first instance is not a joke. So, such kind of technologies the Indian scientists have mastered. And the same thing with the moon. Going to a moon and coming back is not a joke because everything is autonomous. Your systems, as if they have to understand the systems from picking up the images and picking up the environment, they have to adjust themselves. These are all self autonomous mode of working. We have done such kind of things. When Chandrayaan 3 landed onto the moon, the lander, especially working like an independent robo, and chosen the place where to let us say land, and ultimately it has decided for itself how to actually start navigating on the unknown terrain. These are the achievements the Indians have done. This is not a joke. Again, going into the near sun, understanding the what you call requirements of the sun, that requirements of the environment that is around sun. What kind of sun is a god for us, but at the same time, sun flares and some corona particles, CMR emissions, when we call coronal mass emissions, they are very dangerous for Earth because they are all high energy particles. How to, if we get a sign well in advance, we tighten our belts or we safeguard our assets. This mission envisages such kind of things. So the technology is growing, and similarly, like we have a exposat which it talks about, which identifies the black holes, the exoplanets identification. So such kind of things, ISRO when it is doing, obviously the responsibility with these. So people are doing good, are contributing society. I'll just switch over to some interesting topics. Let me just put forth just for, so what we do, what ISRO does it, and some of the things which are not possible for anybody outside people to do. But you are seeing, see, such kind of gigantic production facilities are there, which ISRO does, which for producing the solid motors. When solid motor segments have been done, we have to ground qualify the solid motor. Just see some video I am projecting. You just see the giganticness of these motors. So such kind of things are not available in ISRO. Incidentally, the Sky Route, which is for the one of the private rocket companies, recently the Vikram One rocket was launched by Honorable Prime Minister. The mimic or the model of that rocket has been, the shape and configuration has been unveiled by Honorable Prime Minister. How much effort those let us say the startup boys are doing to graduate to reach to that level, it is not a joke. So these are all test facilities. When once rocket is manufactured, these are all cryogenic and liquid storage engines which are located at the Mahendragiri near to Kanyakumari. We test rigorously. These are all capital intensive facilities. Once, if the people are ready with the rocket engines, they can make use of these facilities to qualify. Launch port. Launch port is another beautiful, that is a system which I don't think 99.999% of the people, they would have not seen what is launch port all about. It is a different world inside Sriharkota, where amazing facilities were designed which are not known to the public. A rocket which was around 44 meters tall. 44 meters means around 130 to 130, 140 meters height. When it is moving on a pad, giganticness will come. So we have launch port, two kinds of launch pads we have. One is the launch vehicle will be assembled on a pad, whereas the building moves. Here, the launch, this is the building, around 78-meter tall building, 4,500 tons building. It is moving away from the rocket so that rocket will be launched into the site. This is one configuration. There is another configuration where the rocket moves, the building is static. See, there are two launch pads in Sriharikota that is owned by Government of India under ISRO. These two launches are one where vehicle moves, rocket is static. Another launch pad is where launch vehicle moves, the building is static. So these are all some of the pictures of I think I have one clipping. Hopefully should. Yeah. This is an assembling rocket. The rocket will be standing on a pedestal. The platforms will be folded so that people will get into different levels and assemble and test different rockets. And once a rocket is relieved by the thing, the rocket will move on a pedestal. We call it as mobile launch pedestal because it is moving out. You see the rocket is moving out of the building where building is static. This is the concept we call it as ITL, integrate, transfer and launch. When you are standing in front of this weapon, this is my usual days, 18 years I have spent here. Whenever we walk along with the rocket, it gives an immense happiness. We are going for third launch pad. Then what satellite does? Satellite we manufacture in URSC, Bangalore. These are all separate clippings of the satellites. The satellites are, each satellite may be somewhere varying about from 1.5 ton to 6 tons. It will undergo several tests before before getting integrated into the launch vehicle. Pardon me, it got stuck. So after doing all these things, what we do? Ultimately, the whatever we do, it has reached to the society. We have conceived a program called Space Tutor. Incidentally, some of the people are got stuck. Pardon me. Yeah. And I want to show a couple of things. I don't know. I'm not able to because my God system got stuck. Never mind. Okay. So these are all the things which we do in ISRO. And obviously, when scientists are doing their job, what kind of jobs that you people will do? First is you dream. If you want to become a space scientist, or if you want to become an ecologist, want to become an agriculture scientist, or if you want to become an astronaut, please dream. When you dream, then you will start acquiring, or you will start acquiring the skills. You will get to know what you have to do, whether it is engineering or whether it is sciences or whether it is mathematics. Ultimately, you will frame up what you wish to do. Nowadays, there is no bar on anything. Let us say government is giving huge amount of encouragement through grants. If you come out and if you want to become an entrepreneur, crores and crores government is pouring. Now new technologies are coming. See, recently you have seen the wars, how the wars are happening. The wars are basically, there is only going to be two important wars in the future. One is space war, another one is cyber war. In the space, you are locating where, because see, obviously the battlefield with guns, with what you call your tanks and all these things gone. Then the second thing is air. Anyhow, airstrikes will be there. But before airstrikes, how the aeroplanes are controlled using ground systems. You have a control room, you are fixing the coordinates, and you are guiding the aeroplanes to go and target and fire. But for that one, ground intelligence is required. Ground electronics are required. The best way of killing the war is go and hit that radar or go and hit that control room. When you hit that control room, you will never receive any message. Any pilot or anybody will never get any message on the ground coordinates where to hit. What happens? The enemy plane will come and hit the offender aeroplane, and that there ends the war. This is called electronic intelligence. Now, the satellites containing alien payloads, we call it as signal intelligence, we call it as electronic intelligence. There are special types of payloads. These payloads, the satellites, I will identify where the ground radar is, where the ground electronic control system is. Then they will be hit. They will be hit first, so that the entire infrastructure will be perished. So that when control is lost, then where is the use? Wherever aeroplane is there, whether it is warplane or it is immaterial. The other fellow, they say the enemy's planes, we can go and hit and we can just blast them. So these are all the new areas that are coming up. And in future, some more technologies are coming up, that is quantum technologies. Today, analog systems have come, very old. After that, digital systems have come. It's all next generation. Then semiconductor revolution have come, nanotechnologies have come. Whatever you are carrying 1 kg, which will be just replaced by 1 gram. That is the nanotechnologies that we are talking about, even less than 1 gram. A big what you call radio or TVs are getting replaced by a small, let us say, mobile kind of iPads. These are all nanotechnologies. So like that, quantum is coming up. When a quantum systems are coming in the flash speed, the things will move with a flash speed, one in million speed or one in lakh, let us say, times. The things will move. These are all quantum technologies that the technologies are picking up. Laser technologies, this is another area where you have a very sophisticated and safe communication that is happening using lasers. There is another technology that is picking up now in the communication front, especially. The optical technologies are totally controlling hyperspectral, multispectral kind of thing. Because anything, see, on the other day when I was visiting the universities, how a thief can be caught. Because if thief has become thin, let us say he was bulky, then at the time, let us say, some police people have taken photographs. And he has done exercises, warming, everything has done, he has become thin. With the body movements, with anthropology, you can still find the thief using artificial intelligence. How the technology is coming into the social life, how the technology is enabling you to live very happily, how the technologies are leveraging your, let us say, day to day life is an important subject that you have to learn. How these technologies you can pursue, how to create interest among these technologies. What are the technologies that I was telling? Signal intelligence, electronic intelligence, lasers, then drones, then hops. Hops is another thing, because drones, anybody is coming and killing. Okay, when they fly in 10 kilometers or 5 kilometers, they say they from the guns they will fire. Then high hops have come, that which will go to 30 kilometers, and still they will do their own job. So 30 kilometers firing is not so easy as you fire in 1 kilometers or 2 kilometers. After that, balloon technology is coming. Balloons also will go up to 30 to 100 kilometers, and still they will carry different payloads. So these are all the new technologies that are coming up. Different startups, they are working on these technologies. The government encouragement, science and technologies, the government encouragement is herculean. I think there are no words to explain how this government is encouraging the young blood and young scientists, young enthusiasts to come out with. Don't harp for, but only thing is, at this age you have to dream, and you should get to know. People are there, STEM and space, like that, people are there. They will bridge the gap between the what you call the available technologies, what is happening around the globe, what frugal technologies or for core technologies are happening, how they will take shape after 4 years or 5 years by the time you come to graduation, what kind of maturity will come, where you will fit in. Semiconductor revolution is coming. See, once we had IT revolution, olden days when you call, probably at that time green revolution was there, white revolution was there. We only, they're all survival benefit, survival kind of this thing. In 2000, IT revolution has come, and last 10 years, biotechnology revolution has come. Now the space revolution is coming out. The space, whether it is for defense or for whether it is for communication or whether it is for scientific exploration, the space, the revolution started. The cyber civil revolution is another revolution. The semiconductor revolution is another revolution. Semiconductor, basically, they will help many technologies cutting across. These are all enablers. Okay, when you wanted to drive a technology, you should have a strong footing on the manufacturing. So the semiconductors basically support all these defense technologies, your aerospace technologies or space technologies or consumer electronics technologies, so that we have to develop our domestic markets so that our dependency on the foreign markets will come down. Today, why other countries are threatening us? Because we have dependency on the other countries. Some are inevitable dependencies like fuel. We don't have fuel. We don't have rare earths, but we have human brain. How actually this human brain we have, the India is having, I should say that 60% of the population is below 30 years, which is a very, very rare thing across the globe. Even Japanese facing the problem. They are looking for Indian manpower. Germany, they are looking for Indian manpower. All countries, Canada is looking for our manpower. Why? Our DNA, our blood is intelligence. That is our asset. We have to capture that. And all these kids, you should be proud enough in another 4 to 5 years, if you are in the 10th class, maybe after 2 years or after 6 years, by the time you complete your graduation, where the world stands, which are all the important areas the world gives you an opportunity to stay, you should know right now and start dreaming it and collaborate amongst yourself, form friendships among yourself. That's how the startups will form. Like-minded people, they will come together, they will work for. Then you have parental support, you have mental support, and you have government support and dependency on, rather than asking for what job I will get, you start giving jobs to the many people. It is very easy to say but difficult to preach, but it is not impossible. It may be difficult, it is not impossible. So I wish you all the best. And my request is dream big. Don't dream small. Dream as much as possible. You dream big. Somebody says aim at Mars, at least you will land on moon. Okay. So if you dream big, at least you will land somewhere at a comfortable position, and develop the attitude to see some of the, because ISRO has got a very good amount of videos, very good amount of what you call literature. I don't know, if you want, I can just show a minute how actually the ISRO. I don't know how many people are.
Yeah, many people are watching, so please go
Ah,
ahead, sir.
okay, watching. Fine. So I'll just take one. If you go to ISRO site, just go down and you have some kind of bullets here, spark. This spark, when you go, in fact, I was the person who was there who made this spark implemented. This is a virtual park. If you enter this park, Initially, you have a small video teaser. Never mind, you can stop, proceed further. You can skip it. Leisurely you do it. This is a walkthrough. What it contains, it talks about. This is a walkthrough. You just go to, you click on these arrows, they will be navigated. You just go inside and you just go to the launch vehicle gallery. On the other side, satellite gallery is there. I think my bandwidth is little bit. So here in this gallery, all PSLV, GSLV Mark III, everything is there. They have, yeah, they have documents, images. See, from C7 to C1 to all the things you have images. You can download the images. And in the same way, you have videos also. There are a number of videos are there. How this called this Aditya, how on board Aditya. Like this, there are these galleries are this is called GSLV gallery. If you just go to the GSLV Mark III, you will have Chandrayaan 4, Chandrayaan 3 missions, all videos. This is the repository of all videos you have. Please have a look at this one. Then if you come out of the gallery, you will go to the, yes. You come out of the building. You have navigation also. Enter the theater. There is a theater, virtual theater we have created. So in this theater, you have so many videos you have. You can just glance through all these videos. You will get to know what are all the, you can increase your size screen also. You can enjoy the entire digital museum. And you have another thing, STEM. If you go to this site, you'll have lots of material, study material. This exact material is talking about whatever the Uvica that is there, overlay of science and space and science applications. It requires a registration, of course. Otherwise, if you go and if you just go through this site, this is exactly the Ubica material. Those who 8th class, 9th class, who miss it to get an opportunity to join Ubica, never mind. You have all the contents. Whatever is taught in Ubica, that is posted here. You can just go through, register yourself, and it's a certified course. If you go through all these things, you will get an online certificate also. So this much we have provided.
So you're saying the Ubica, they can, I mean,
Yes.
we all know Ubica is a program that you run,
Yes.
but they can click on the Ubica link and go and find material under there.
Not Uvica, just I have showed, the Siksha Gagan.
Siksha and the virtual museum
Yes,
has a lot
yes,
of
yes,
videos.
yes.
Yeah,
Virtual
yeah.
museum.
Yeah, thank you for showing us that. I've seen the Spark, but I've not gone in and explored all the videos. So yeah,
Yes, yes.
we can show that to our students.
Yes, yes, yes. Okay. These are all the
Yeah.
treasure that is available. You can download them, you can watch them, you can participate in different programs. Okay. But
So
my request to you is please enjoy the play and make it as a passion to pursue. To start with STEM, after that space or aerospace or defense, anything. Now India is booming. I wish you all the best. If at all any questions are there, I'm happy to.
Okay, so there are a few questions I'll bring to you that are about the kind of slides you showed about technology, and then there are some career questions that I'll bring separately. Okay, so when the rockets get launched, it creates a lot of pollution. So will there be any future technology that will stop the pollution? And I'll also ask another question that's related. What can be done to reduce the problem as rockets take a huge amount of fuel?
See, it's not called pollution. These are
Yeah,
all
smoke. Yeah,
pollution when it becomes nuisance for the people around. First is a rocket when it is firing around 7 to 10 kilometers around that, not even a single soul will be there. First,
right.
that point
Yeah.
to be noted. Second thing is these are all fumes. These are all fully, I should say, burnt gases. In terms of fumes, it will go. And yeah, okay, fine, that's okay. Fine, the water molecules will be injected to suppress the acoustics, but this is not a pollution proof. And the burn ratio they will adjust in such a way that it will complete the combustion would be as maximum as possible, so up to 90%, something like that. It is not a pollution, first of all, and it is one. Second thing is, even if pollution is there, after some time it will settle, and the entire 12 kilometers radius, nothing is there. It is on the sea coast. It is not going to create any kinds of pollution. The second thing, what you asked, something fuel, something you asked.
Yeah, maybe the new kinds of fuels that rockets may be using.
Okay. See, today the because we call it as ISP, whichever the fuel has got highest ISP, that is the best fuel. But as you said, some of the fuel causes some dangers. Dangers means, let's say N2O4 and UDMH, which is we call it as earth storable. That is very toxic in nature. And if you say solid propellant, there is a danger that they may explode and causes, let's say, the largest causes the human, let's say, danger. Okay, if it is cryo, maintaining cryo is very difficult because minus 200 degrees, minus 150 degrees, if you do, and it's very difficult to manage the initial thrust, the levels. So now, a good thing is the liquid methane, which we call it as green propellant, that is now picking up very fast. Semi cryo, it's a semi kerosene, we call it as. Cryo means is a refined kerosene that we call it a semi-cryo stage. This is very, very harmless. Using the liquid oxygen, the stage will be formed semi-kerosene plus liquid oxygen. The new development that is happening is liquid methane. Liquid methane is a green propellant, is much having much less hazardous things. Okay, the developments are happening. Our NGLV, the next generation launch vehicle, we are planning with the liquid methane and liquid oxygen. These are all the safe fuels.
Yeah, thank you for that, sir. So one question is, you showed all these pictures. So one question is, how are these big rockets transported to the launch pad?
See, launch pad, the launch vehicle per se, it will be assembled in vertical condition. It is not that entire launch vehicle like Soyuz. See, there are different modes, The Soyuz, they will assemble in the building and in big stages, and it will be transported horizontally. But any rocket is built out of stages. Let us say if we take PSLV got 4 stages. The first stage is S139. Again, that is made up of 5 segments, and each segment again, if you say the nozzle, if you say the core base shroud, in the individual units like that, they will come. They go to the launch pad. One after the other, they will assemble. So first thing is what I said, something which is assembled right on the pad. Another concept is they assemble on a pad, the pad itself will move. So the rocket movement, you see, I've shown you, there is a big pedestal on which the rocket is assembled. The entire mobile pedestal will move on the rails from assembly building to the launch pad in a vertical condition. The beauty of it is There is no guy wire. It will be standing freely. That is called rocket science.
Yeah.
Yeah, I had another related question. And Garvit, if you also want to take any, but is there any relation between space exploration and ocean exploration?
See, exploring space is space exploration, exploring ocean is ocean exploration. Using the satellite, exploring ocean, yes, it is there.
That's right. Yeah.
Okay. See,
Like you showed that the satellites are actually taking images of
yes, yes,
whole
yes.
of Earth and different
See,
resources
we
of Earth.
have we have ocean sats. See, in
Right.
ocean sats, what we do? Let us say one is ocean temperature monitoring, then ocean color monitoring. When ocean color is monitored, based on that one, we will guide the fishermen where the catchment would be more. Ocean water temperatures monitoring, that will give an idea that how actually shipping industry will be enabled. Okay, then atmospheres in the oceans, there are some kind of currents that will be studied very carefully, how actually the migration of these waters take place for different reasons. Then atmosphere, how the ocean parameters, where the heat is beginning, where the vacuum, the what you call the cyclone formation is happening. See, these are all ocean studies, and important is marine assets now being monitored by satellites using different payloads like your X-ray payloads or some kind of spectroscopic payloads. We can find out at a proper depth. It is not possible to go into the much deeper depths. At shallow
Right.
regions, if you have minerals, if you have corals, if you have any precious material, you can identify. This is called our blue, what is that? Blue economy or something like that we have thrown, no? Exploring the assets inside beneath the oceans.
Okay.
Satellites, many satellites are there for
Right.
cargo monitoring. When ships are
Right.
moving across the globe, how actually their navigation is monitored, these satellites are being used. Many applications are there.
Right. So you discussed a lot about how to get into space careers, and again, sir, uh, we have learned a lot from you, and hopefully we can also take it forward to students. Garvit, you want to bring forward a couple of the career questions?
Yeah,
Yeah,
please.
so there were a few career questions also. So, like someone was asking that what degrees or what educational paths would you recommend for aspiring professionals eager to enter the space industry?
See, space means not rocket or not satellite. Even if it is a satellite, it contains communication engineering, it contains sensor engineering, it contains, that is, instrumentation engineering, it contains bioengineering, it contains, let us say, what you call atmosphere sciences. So you take any name of the discipline that ever exists, that can be linked to the space. Only thing is some engineering will be applicable. Biotechnology. Today, Gaganyaan, when you are going, all experiments are related to bio. Your organ transplantation, how actually organs can be built in space manufacturing, we call it as.
Mm.
What is not there? Even agriculture growth, how actually the seeds will be developed, that we are talking about in the Gaganyaan. So any engineering that ever exists will find an application using the space technology.
Right. And
Also,
of course, yeah, go
yeah,
ahead, Garvit.
someone just asked a one-line question that how to join ISRO.
Simple. You have to
So,
first
if you can
qualify.
shed some light.
If you want to get a lottery, you have to buy a lottery ticket. Okay. To become a ISRO scientist, first is minimum qualification is graduation. Okay, if you want to become engineer. Okay, other designations are also there, technicians and
Right.
technical assistants. You keep watching the announcements because it's a government organization. Government organization recruitment is guided by some rules and some kind of procedures. There is an ICRB exam usually that will be conducted twice in a year meticulously. Many competitive exams are not running, whereas this ICRB very meticulously they run every year twice. The graduates whether it is mechanical, electrical, civil, electronics and communication, computers, IT, metallurgy, chemical. Everybody will have some positions or not. Okay, they can apply, they can write the exam, they can get into the, because see, everywhere you have to manage 140 crore people, out of which 60 crore students, means a filtration process is inevitable. You have to be competitive and you have to be knowledgeable. The questions are available in the site. If you just Google it out, ICRB means ISRO Central Recruitment Board. The question papers are available. You can try your luck best. Otherwise, space industry is picking up, and the whether it is rocket manufacturing companies or satellite manufacturing companies or satellite application, what you call development companies. Okay, whether it is a communication, because you are seeing when you are running one satellite, means obviously even for the ground systems which Airtel or Tata Sky, how much ground support is required. They are all jobs. They are all ultimately creating the jobs for the students.
Right. So, sir, one question is, and we have some idea, but maybe you can give us a glimpse of what are the future upcoming missions of ISRO?
Yeah, next to that, one AST mobile launch is lined up. Actually, 15th it is supposed to go.
Okay.
But there is a small delay. After that, there is an Ocean Sat, which is the first industry led consortium launch vehicle, is also planned soon. Okay, we have Gaganyaan missions, we have private launches, because no commercial launches are very many. Okay, as far as the thing is, next leap should be Gaganyaan only, because which will create the impact like Chandrayaan 3.
Right.
People will be looking for, because scientific missions we are on the plan of creating. Otherwise, some remote sensing satellites, all these things will be there. These are all, you will be available. If you Google it, you will get the
Right.
manifest
I think
details.
Gaganyaan and maybe Chandrayaan 4 when that comes up.
Chandrayaan
Those are the
4,
two big
some,
ones.
some more time is there. Chandrayaan 4 requires mission planning, and because it's a very, very, very complicated technology,
Right.
not a small technology. But Gaganyaan, yes, uncrewed missions, crewed missions are planned soon. We have to complete these missions as early as possible.
And what role do you think international partnerships will play in advancing our goals for space exploration?
See, right from the day one when we have started our space journey in India by Vikram Sarabhai, till the last mission, Chandrayaan 3, which is, there is no prominent mission has gone successful, whether it's an Indian mission or scientific exploration missions. I'm talking about not commercial missions. Let us say Elon Musk is launching star satellites. I'm not talking such kind of commercial missions. If it is scientific exploration, including ISS, there is no single mission which has gone without international collaboration. Okay, our own missions use it. Chandrayaan 1, the water molecule was found out by the payload which was given by NASA. Chandrayaan 3, when we have done the launching, we have taken support of JPL, so many ESA ground stations. If you are conceiving Gaganyaan, this is an international collaboration. We are getting astronaut training from Russia, then payload, the communication training from Kennes. JPL is supporting us. In NASA, of course, Axiom, through Axiom, NASA is supporting for continued training. So international cooperation is a basic requirement and basic understanding and protocol for space exploration. That is nothing to tell JAXA. We are going for JAXA for Chandrayaan 4 mission, and we are launching our payloads in their missions. Like Axiom mission is one perfect example. We have put our astronaut in their mission to send to ISS. ISS itself is Japanese, then USA, the USSR, Russia, is a collaborative approach. So international cooperation is inevitable in the space exploration.
Yeah, and it's great to see that even the recent NISAR mission.
Yes, Nisar mission. Yes, I forgotten
Right.
that one. Yes.
Right. So with that, I think, sir, that we have brought a lot of questions to you, and you've given us such informative answers. And I hope students can, take forward and look up the kind of things you have suggested, and the website, on the ISRO website,
Yes.
you've pointed out the links that students can access. And we also are, proud to be registered with ISRO as space tutors. And with your advice, we will take forward some of these things to the students. And thank you, sir, for
Thank
coming
you.
here today and giving a wonderful session where students have so many questions, sir. We only brought you some meaningful ones, but that means that students are watching very carefully and they are very interested in this topic.
Thank you. Thank you. Okay, bye.
Okay, bye everyone, and
Thank you.
thank you, sir, again for joining. Thank you, students, for sharing all your questions and showing your interest in space.
Thank you.
Thank you.
Thank you, sir. Bye bye.